So, a question will fall under the category of small changes or approximate changes when a small change in one variable causes a small change in another variable. That is, only when this change is small enough and not like the variable level. Not like the variable. So, let's say if x goes from 5 to 5.01. This is a small change, and we can be asked to calculate the small change in y. If the small change in y when x and y are related by an equation. In order to calculate the small change, this is the formula which we'll use. The concept is that sy over sx is equals to dy over dx, where sy is small change in y and sx is small change in x. Using this concept, you can rearrange this to suit the needs of the questions and you will eventually solve the question. We'll have three examples. The last example is most interesting. First of all, find the approximate change in y if x increases from 2 to 2.02. Alright. And x and y are related by the equation this. So the first step is going to be, it's usually always going to be finding dy by dx. In this case, we have 6x and minus 5 as the derivative. We substitute the original value of x, so we will get dy by dx is equals to 2. No, rather 12 minus 5, which is 7. Mind you, always substitute the original value. Moving on, I write this down too. Substitute the original value of x. And then a small change in x is what we need. Final minus initial is equals to 0.02. That's a small change in x. And finally, to calculate the small change in y, we'll use the formula dy over dx into the small change in x. Dy over dx is 7. We calculated this here. And the small change in x is 0.02. So 7 into 0.02, and this turns out to be, just a second, yeah, it's 0.14. This is our final answer. Moving on, given that x and y are again related by an equation, and x increases, again x is the one changing this time too, from 10 to 10.5. Find the approximate change in y. Alright, it's a similar question. Again, usually the first step is always finding dy by dx, but before that I'll rewrite the equation of y so it becomes easier to differentiate. So dy by dx is bring the power down, reduce the power by 1 into differential of the bracket. It simplifies to give half, or rather it simplifies to give 1 over root 2x plus 5. Again, we'll substitute the original value of x. I'll copy this now, write this here too so you guys remember. And then once I substitute the original value of x, which in this case was 10, the simplified value of dy by dx is 1 over root 25, which further simplifies to give 1 over 5. Alright, So I have dy over dx, and what I need is the small change in x, which is 10.5, that is final minus initial minus 10, so I have 0.5. Finally, again use the formula to calculate the small change in y, dy over dx into small change in x, dy over dx is 1 over 5 and small change in x is 0.5. I can rewrite this as 1 over 2 and yeah. Small change in y is going to be 0.1 and this is my answer. Then our last and final example. This is my favorite particularly. So we're given that x and y are again related by the equation this y is equals to 9 x exponent 2 over 3, and this time the, this the concept is that y increases. This is the trick. So since y increases this time, we need to find the approximate change in x. And mind you, y is also the subject. So the steps are similar but kind of different. I taught you that sy over sx is equal to dy over dx. This is always going to be the concept. And this time, since we need to find small change in x, I'll rearrange this formula and I'll get sx is equal to dx over dy multiplied by small change in y. Mind you, not to be confused with this, since this is simply the reciprocal of dy over dx. So start by finding dy over dx, bring the power down, reduce the power by 1, and you will end up having 6x 6 over cube root of x. Substitute the original value of x. So I have 36. Oops. So the cube root of 36. Okay. So this is the mistake you guys made. So this was the original value of x, of y rather, and this is not the original value of x. So there's gonna be another concept. Using the formula to find the original value of x. The reason I made this mistake was I wanted you guys to learn that what is the common mistake students make, and so you guys don't make it yourself. So the original value of x at the point when y is original 2 is 8, and 6 over 2, and my dy over dx turns out to be 3. Then the small change in y, I need a small change in y here. It's 36.3 minus 36, which is 0.3. Thus, using the formula which we derived, Sx is equals to dx over dy into small change in y. So, I told you guys that not to be confused by this is simply the reciprocal of dy over dx. Since dy over dx is 3, dx over dy is going to be the reciprocal, that is 1 over 3. Small change in y is 0.3. That's my final answer. Turns out to be 0.1. And this is where we wrap up small changes and approximate changes.